the number one concern that I, as a software developer, have is the idea of putting my code in the hands of the enemy. And hey Ben, how's it going? I haven't seen you since we were hanging out in Austin. And when was that? Was that July?
Yeah, it
June?
was consensus. So June, maybe. Yeah, it's been a couple months. Yeah,
Yeah, it's
it's a
awesome
good
to
time
see
though.
you. Yeah, there's a lot of activity right now on on both sides of this fence. I'm going balls out on getting Mooncast going, and I see a lot of cool announcements from Deep right now.
I think the big thing for us is we're seeing a lot of people get more interested in how to actually make nodes useful, right? Like, I had a conversation with a, a node creator yesterday, and I won't name him, but they've got a lot of nodes out there, and the system that they're running all of it on has basically left them completely incapable of using those nodes in production, right? So they've replicated all of their services. They're running everything on AWS, but they're still minting all of these tokens to give out to node holders, right? So it's like the worst of both worlds, where you're giving out all your token and you're paying out cash to AWS, right? And
Yeah.
so I and he's coming to us asking for help at NerdNode and DeEEP, and it's exactly what we're working on, right? And I think we've got a solution we can get him enabled with, which is exciting. But we're seeing this across a number of different projects right now. We want to build a node, we want this to be decentralized, but how do we actually do it? Where do we actually run it? And those are the pieces we're trying to like coach some folks through right now, which is a lot of fun. It's also a lot of work, but the nice part is it's really giving some legitimacy to the projects we've been working on. That people are recognizing that kind of this promise of Web3 nodes, it only becomes real when you have the whole ecosystem. It can't just be, oh, here's a node, go run this anywhere you want with no security and with no reliability and all of that, right? So,
For
yeah.
sure, yeah. When we were talking about running nodes, I had architected the server set so that there was a place where the users would connect through, and then all the traffic would go through those nodes.
Yeah.
And the intent was we could actually, distribute those nodes all across the world, and that way you'd connect to the closest one, and that would kind of work like a VPN. Because weirdly enough, with the open internet, if you're just connecting to a random server somewhere, it's not uncommon in the United States. We'll go through like 4 or 5 hops or something, but in
Yep.
some countries, you'll end up going through 20 or 30 hops before you
Right.
finally make it to a cloud OC3 or some bigger connection that actually is pretty well connected to things. And your latency is horrible. And honestly, a lot of times what I found is that people going through a VPN would cut a lot of the hops out. And it's not necessarily faster, it's just fewer machines waiting to touch your packets before finally it gets to the destination. And it would perform better. We'd see people have connection times of up to 3 seconds to make the initial connection. And then
Yeah.
they go on VPN and it would be like 1.1 seconds or less, which is
Interesting.
insane to me.
Yeah.
But that's just the internet that we have at large. And so when we started seeing these things, I'm like, well, how do we make it so that we can make our network feel more like you're connecting to a VPN, is to distribute the edge servers throughout the entire world. And that way you connect to the closest one. And that kind of works the same way. And, we thought about, wouldn't it be cool if we could also run zones on machines that are co-located in various places? And that's when the security issue came up. And we
Yeah.
started thinking, like, how do we make a game with validation, right? If you want to run 3 versions of the game and you can't have a random number. You can't, like,
Yeah.
it becomes really, really complicated to build any complicated game where you can't have multiple threads running. You can't have random numbers being generated. You can't, and the validation of those things is super complicated. So it doesn't usually work for a video game, but there's lots of other products that it does work for, to just have validators or do things in distribution and decentralize them. So in my corner of the universe where Mooncast is, we started thinking about, like, how do we build zones in a way that that maybe takes advantage of having this architecture where we have a central zone someplace that you connect to and do authentication and things like that. But beyond that, let users run those nodes and let them actually be able to run and host things for us, and we could reward them and start from first principles with the intention of players or investors. I want to call them investors because that was what they would be. Investors owning and operating some portion of the infrastructure for our game. And
Yeah.
that's a bit different than how a lot of games are approaching it. But yeah, the most critical, and we talked about this back in during consensus, is that the most critical part for us is that we have to trust that these are actually running our software, that it
Right.
hasn't been tinkered with, and that there isn't anything happening that people could inject data or change. And so, if you want to like tell me a little bit more about the deep boxes, because I know that that's something that for me to be really completely satisfied with the security would make it possible for us to eventually sell nodes that actually do something.
Yeah, and I think so. Security, in my opinion, is one of the things that we're really building at NerdNode and Deep to set us apart. Right. So in crypto, this idea of trust and trust versus trustless is a huge aspect of our culture, right? But ultimately, for societies to function, there needs to be trust somewhere in a system, right? We need to say, like, okay, these this is how I know this is genuine, right? And with minting a fungible token, and doing that by mining, that's super easy to mathematically prove that trust, right? We can say how that was done and track all that on the blockchain. But when we start moving away from like mathematical proofs for how we have trust, there has to be some authority that can come in and say, yes, we've put some level of security and trust and authorized that this thing is genuine and isn't compromised, right? And so anytime we kind of look at trust, the way we've been thinking about it is we want to build trust in trustless environments, right? So in general, if we put out boxes, and so DePIN is effectively putting out devices anywhere in the world, and they join this big network and participate, right? Well, that sounds great until you think about the realities of once you get physical access to most devices, um, you lose control of that device, right? Like
Mhm.
hackers, I mean, I've hacked lots of hardware devices in my day. I hold 2 black badges at DevCon, the world's largest hacking conference. Like I've done a lot of this type of stuff. And making sure that a box is secure is quite a challenge. And so what we've really focused on is starting from the ground up of saying, okay, how do we make sure that if I put, this box in a home of somebody that I don't know that might be Uber hacker number one, right? That the cost and difficulty for them to break into this box is quite high. Um, and if they do succeed in breaking into this box, a couple things happen. Number one, we know about it, right? So we can revoke that box. And the exposure level of a hacker getting into a single box only exposes them to that single box, right? They can't compromise the rest of the network in that process. So we've really focused on kind of building up those pieces to make sure that we can send these boxes, these devices out anywhere in the world and run workloads on them that we know are secure from a malicious person like sitting in front of the box, right? So that's one of the security vectors. And we've implemented a number of things for that. So we're doing secure boot, which basically checks signatures of each step of the boot process from the BIOS to the bootloader to the OS and then into the virtual machines where we run all of these. We check each stage that they're signed by an authority, and that authority in this case will be DeEEP Network. Um, And then on top of that, we're doing what's called measured boot. So even if somehow somebody got a hold of or faked a signing key or bypassed that, we're actually measuring to make sure that that didn't change from the last time it booted, and that happens from every boot. So if somebody goes in there and monkeys with some of the changes or try to change like the kernel commands for how you launch Linux, it'll recognize that and say, oh, nope. And we are doing an A/B boot system where it'll automatically fall back to the last known good boot state. So we all had a global outage a couple of weeks ago, right?
A global tech outage is disrupting companies around the world, from airlines to broadcasters and banks.
Massive global technical outage tied to CrowdStrike, which is a major cybersecurity provider, has knocked critical computer infrastructure offline all across the country and, in fact, all around the world.
So we're putting in pieces that intentionally go in and say, okay, if there are these types of failures, it automatically fails over to a last known good state that was authorized, right? And so we continue to kind of these processes up the chain to make sure when we get into we run everything in Linux, DeEEP Network. When we're in Linux, we can then spin up VMs that are isolated from each other, and we run individual workloads, so individual nodes or services, different things that get added to the network, get run in these VMs that are completely isolated from each other as well. And so what this allows is, if we put your game on it or anybody else's game on a different VM, they can't talk to each other and mess each other up. And at the same time, like, we're giving you that authority and security that nobody's tampered with that process going all the way up the chain. And this is very different than what we've seen basically anybody else do in DePIN networks so far. And really, even in data centers, a lot of this is just starting to happen over the last couple of years because that data center has been behind lock and key, right? Only certain known people are allowed into it. So, this security level doesn't even exist in a lot of those environments because they're badge access effectively, right?
Yeah.
Yeah, so that's kind of where we're heading. And I have done this in my past in the IoT and edge computing realm. So like every McDonald's worldwide has five boxes that I was the CEO of a previous company that designed these. And they're all this same level of security, right? And went through all the audits of a Fortune 10 company that's trying to, buy these types of devices. So I've been through the ringer on how to build these types of devices and deployed them at scale, globally, remotely managed in unsecured locations. And so we're taking a lot of those lessons learned and applying them at DeEEP as well.
That's awesome. Yeah, that's the number one concern that I, as a software developer, have is the idea of putting my code in the hands of the enemy. And because
Yeah.
I mean, that's not to say that I expect every person is going to be a hacker. It's probably very unlikely, but the most likely one hacker that gets a hold of something and can do something devastating to it, that's all it takes is one, right? Hackers are not about everybody being a hacker. It's about the one hacker exploiting something in a way that other people can't. And
Right.
and that's where having security that one tells me as a developer that I could run something on one of these devices and know that it's the same or better than trying to run this in the cloud somewhere. Because if someone gets a hold of my cloud keys, they can go and do everything that they want to my code, and I don't necessarily know about it. But if this is running on a device that has been secured and that device is compromised, then your network can figure that out and isolate that box, right?
Correct. Yeah, we can shut that individual box out of the network if it fails its authentication effectively, right? And so that's really what we're trying to build. And I think the reality is, as software engineers and hardware engineers, like, hackers exist, and with enough time and money, any system can be broken, right? And so the trick for us when we think about how do we develop things is how do we limit the exposure of when that hacker does hack something, right? Because we all rely on libraries from third parties and all of that, we don't have full control of everything we write, right? We're relying on a huge swath of open source and closed source software that has vulnerabilities, right? And our job is to make sure the intellectual property that we're creating for ourselves and for our customers has the least exposure when that hacker eventually gets in, and that devastation you're talking about is minimized to a single location that's easily replaceable.
When you think about banking, and literally everything crypto is banking, when you think about banking, there's a tremendous incentive for someone to find a way to hack into something, because they can then acquire value directly,
Right.
and take it and move it to their own wallets and do whatever they want with it. So I take crypto incredibly seriously, and I take security incredibly seriously, to the extent that when we were doing any of the stuff that like creating Docker images and things like that for our containers on Miranda's, and I do the same thing now, I freeze everything. Like, I have version numbers pinned. I make sure that everything that I'm doing, I'm not taking latest, because once I've verified something works, it better stay that way until I'm ready for me to upgrade it and retest everything.
Yeah,
and
keep it atomic.
At the point where if I can say, like, this works and I feel confident about it, there still may be vulnerabilities in it, but it's the ones that I know about.
Right.
And then I can run that someplace. And ideally you find an environment that is secure enough that you can run things in it that what those vulnerabilities are, and maybe you can defend against that, or maybe you can upgrade them whenever you need to, or something like that. But having that measure of control is so important, because you have to respect the value that people are placing, the trust that they're placing in you to handle their value. That's basically, like, we're building banking software. It may be skinned like a video game, but it's still essentially like banking software, and we have to take it very seriously. And that's something that video games normally don't need to do, because things that you have in a game stays in the game, and the value is only how much time and effort it took for you to go and acquire it.
Right.
And that is something that I think some games don't respect very well, unfortunately. Bugs make you lose an item that you spent 3 weeks looking for, and then there's no recourse. I think that's a little bit different in the kind of product that I'm trying to make, where it could be someone walks in and spends 3 or 4 months trying to build something, or maybe they come and bring a lot of money and have acquired something through other people's efforts that took 3 or 4 months, and a bug that causes them to lose that's not okay. Worse is when a hacker figures out a way to say, oh, I'm going to take this item from you, even though you haven't interacted with me, but I found an exploit in the game, or I found a way to modify the server that's running this zone, or whatever. So that's why I'm excited about working with you guys. I'm trying to find a way to, one, know that whenever my process starts up, am I actually being run on a DeEEP box, or is this somebody who's found a way to run my software somewhere else? How do I know that something is running on DeEEP?
Yeah. There's a few pieces we're working on there that will basically allow us to do. So we have a key, a root of trust key, put in the TPM, which is the trusted platform module of the box. And that is hardware. It's immutable, effectively. We can erase it, but you can't, it never leaves. That private key never leaves that piece of hardware. So all that we can get out of it is a public key. So effectively, what I think we can do for your verification is give you the private key. You sign something with it, send it as a challenge to a DeEEP box, and then we'll be able to return the nonce effectively that you sent. And I think the piece there that we just need to make sure we've got is kind of that lookup directory of, okay, what are the private keys or public keys, that are expected for each box, and we're publishing that in probably on somewhere on chain where you can say, oh yeah, I know this is a DeEEP device. So I think that's something we can work through, and I think we've got the right pieces in place. We just need to make sure that the directory for you to say, oh, I'm talking to, box 123. What's the public key for box 123? Now I'll send it a challenge, and then get if if that challenge is returned with the nonce you expected, would be, validated that it's the appropriate box, right?
Awesome. Yeah, that was one of the things that I was like, okay, so if there's ways that people can hack my system, it might be easy for them to set up another node that isn't inside the network. So I need to verify that this is actually coming from inside the network to begin with. But yeah, that was one of the things. Like, yeah, I got to figure out how do we make sure that exists, because
Yeah.
someone running outside of the network means that they're not secure. And if I just trust that anything that runs is going to be secure, then I'm actually opening myself up to all the hackers again.
Yeah. Yeah, and it's a hard problem to solve too. I mean, we're working with some partners on some of this, like proof of location and proof of bandwidth, and some of that too. Because those are problems we have to solve. Is somebody says that they have gigabit Ethernet, right? And we are rewarding based on speed as part of the, like, how do we know that you have like good internet, right? So we're working with Witness Chain right now to figure out implementing basically their challenges that all the boxes send to each other of how much bandwidth do you have, and they also figure out location. And with that location, I think we'll be able to show you kind of where things are for people to ping into the closest box, right? We're also planning on using that for things like legal compliance down the road. So if you are operating in Europe and you have to comply with some GDPR compliance where the data that a user creates, it can't leave the European Union, well, our network has to be able to basically say for you, hey, this box is in the right geo zone, right? So it's similar pieces of how do we do these challenges to make sure that we're not letting data leak into places where it's not supposed to be. How do we know we're talking to genuine devices? How do we validate that what people tell us about their internet connection or their those types of things are true, right? Those are, because everybody's going to game systems when they can, especially if there's rewards available for that gaming. So figuring out kind of how to build those is pieces we're working through right now.
For sure. So when I know that there's some people are asking questions about things like, how do I run my nodes, like software nodes, on the physical hardware? And I think some people may even be confused that this is a physical box.
Yeah.
Do you have one of these boxes?
Yeah, I do. This is one of the boxes that we're pushing out. It's a pretty beefy machine. It's got USB ports of power on the front, but on the back, we've got high speed USB here, so up to 40 gigabits of USB coming out of here. So what that's going to allow customers to do is add things over time. So external storage, external GPUs, all of that type of stuff should be good. And then we've got ludicrously fast Ethernet over here. So 10 gigabits, 10 gigabit Ethernet ports. So if you have fiber modem, you can plug this sucker directly into that. Or 2.5 gigabit, regular RJ45 style. Inside the box, we're running an Intel i9 in here. So high-end, professional-grade solution. We've got the TPM that I talked about, which is the security chip. We're doing encrypted RAM, which is pretty rare. Hackers, even if they have physical access, can't put this thing in liquid nitrogen, pull the RAM out, and pop it in another computer and pull your keys off of it, right? We're doubling down on the security here with encrypted RAM. We've got a 1 terabyte SSD, which is NVMe, so they're just ludicrously fast. We've got full-size PCIe slots so that we can upgrade GPUs down the road, those types of things, the USB ports and the Ethernet ports I talked about. And one of the things I want to stress with this project is Like, this isn't a dedicated hardware box. I mean, this is a normal computer. If you don't like DeEEP at some point, you can wipe this whole thing and install Windows or Linux or whatever you want on it. So there's nothing like particularly DeEEP specific other than we've provisioned it from the factory to be DeEEP enabled, right? And so that gives you, as the developer, the confidence that there's that chain of trust that we talked about in the device.
Nice. That's a pretty sexy box. I mean, for what's it going for, like $1,111, something like that?
Yeah.
That
Yeah.
even at that price, just buying a small form factor machine is a pretty good deal. And with all those specs on it, I mean, you could run a lot of cool servers locally if you didn't want to do DeEEP, for sure.
Yeah, we're trying to keep the pricing competitive. I mean, we're buying these in bulk direct from the factory in order to basically make it as cheap as we can.
Yeah. So when it comes to running things on a box, and you have a desire to become involved with DeEEP, but you don't have your own software nodes, can I just buy a box and plug it in at my house and then walk away from it and forget about it?
You don't have to own any software. All you have to do is buy the box. So if you buy the box and you have internet and you have power, that's all you need: internet, power, and the device. And you plug it in, and NerdNode and DeEEP take advantage of that box being plugged in. And what we'll do is start assigning workloads to it. And then all of the users get to, or all the owners of these boxes get, right off the bat, you'll get 50% of the earnings of any service run on your box. And then you also get rewards for having it plugged in. So those are part of the minting rewards. So the hosting rewards are when we're running something for somebody. And then the minting rewards is, hey, I plugged this box in and it's part of the network. If you do own your own nodes, and you don't have to own your own nodes, they'll probably get run on your box. But if your box goes down, we're going to automatically transfer those nodes to somebody else's box, right? And that means that you're not missing out on earnings because your internet service provider had a glitch or your power went out because of a thunderstorm, right? And those are a lot of the problems that we see people having. There's also no requirement for anyone to go log into this box and do anything, right? You put in API keys and we take care of the rest. All of that gets taken care of by DeEEP. And most people who aren't software engineers have no interest in learning how to log into a virtual private server and type in all these commands over SSH. That all is really complicated. And now what we're doing is taking that same philosophy and all the lessons we've learned on how to run nodes, and we're distributing that so that Web3 is truly distributed. Because to be honest, like NerdNode, like almost every other VPS provider and all of that, we only have a handful of different locations we run our boxes in. We are one of the few actually in this space that own all of our own hardware, and we have distributed them. But most of our competitors are putting these up on AWS or Vultr or some other similar service, and they're all centralized still, right? And so we're pretty passionate that decentralization is what's critical when we start looking at Web3 and nodes in general.
Totally. Yeah. When it comes to, like, so there's two words that are being bandied about, and I think it's worth explaining a little bit, like what the difference is: decentralized and distributed. Because I know Titan's going to watch this, and Titan's all about decentralized is his thing.
Yeah.
There are things that are distributed and it still has a head somewhere, and then there's lots of little legs that can be all over the place, right? And distributed means that if the power goes out on the eastern seaboard, doesn't mean that the whole thing is down, but the things that are over there on the eastern seaboard are going to be down. Right. And you still have to worry about the centralized piece of it that operates the majority of a network. That still has to stay up somehow, or it all probably falls over. The concern that I think a lot of people have, and I think it's a well-placed concern, is that if everything is centralized and non-distributed, then you end up with a glitch. And it could be, maybe it's not World War III, but it could just be like somebody kicks a cable out of a wall somewhere, and now all of an AWS one of their data centers is completely offline. Right? Having decentralized is even better because that means that almost no matter what happens, you're going to have it running. Like Ethereum and Bitcoin, that can't go down. Like the only way that goes down is electricity across the whole world shuts off.
Yeah.
Right.
Yeah.
That's pretty much the only way. When I started thinking about like, I'd love for Mooncast to run distributed. I want it so that people can run nodes. I want them to be able to actually host functioning zones. Maybe it's on their hardware. Maybe it's just on the DeEEP network. Maybe it's wherever, but it running distributed means we can actually have nodes running closer to where people are. And that helps their latency so that instead of them all connecting to some central zone someplace that's running in an AWS data center, maybe they can run with zones that are closer to their home or wherever they're gaming at that time. And ideally, when this starts running all over the world, we'll have, people in Argentina will be able to play in zones that are running in Argentina instead of having to connect all the way to the eastern coast.
Both being distributed and being decentralized are objectives, right? So we're trying to build this system without a single point of failure, right? I think Titan pushes hard on like, can you push on any one person to like take down the network? And that's when we go back to kind of trust pieces, that's really hard to undo, right? And I think we're looking at that as DeEEP will be a DAO, and the DAO will be able to, persevere through those types of things and put in the right governance pieces. But when we look at the technical side of how we're doing it, we're trying to make sure that like the validators that we put that run the actual DeEEP network are distributed and decentralized, right? So that all the commands for all of the remote devices, all the devices that everyone has, are coming from one or many of those validators. And if one of those goes down, all the devices that were previously attached to that just automatically attach to a different one, right? And keep getting their same commands. So we've kind of got some pretty cool, like, high availability combined with distributed control and decentralized control and distributed devices. So we're trying to make it so nobody can kick out a single cord and cause something to go down. How do we authorize new things to come onto the network, right? And that, I think, is kind of the big one we're still working through. Back to that trust, it's easy to lose trust, right? Like for users to lose trust. And so we are erring right now on the side of maintaining a high level of trust, and that the services that run on these boxes aren't going to put you in any legal trouble in your locations, right? So we're working hard to validate as a team, as a DeEEP network team, the types of services that run on the network. So the part that probably is least decentralized at the moment is how do we put a new service on the network? And I think that's okay right now, because we are building that trust, and we have to figure out how to make that trust capability where people can choose the level that they want to engage in when they put these boxes in their home. And when we start out, we want to keep that trust super high. And over time, we can lower that trust, let people choose to lower that trust level in their own home. But the default will always be the highest level of trust.
The concern I've seen with a bunch of decentralized networks already is that in a decent number of cases, they have no control over that. And so the very first thing I expect to see is a bunch of spammers who want to send out a buttload of emails are going to sign up for those networks. And then they have all these IP addresses they get to use for almost free.
Right. Right. And then they all get blacklisted. Yeah,
exactly. And your box is useless. I look forward to working with you guys. I'm going to have to ping you privately on a whole bunch of other topics very soon. So expect a deluge of emails. And well, I don't email anymore, but I'll ping you on Discord, and we'll start getting the wheels moving on this. So
sounds good. Yeah, and I think we've got some boxes now in the office. So you're one of the first ones who bought anyway. So I think we'll be trying to get something out to you soon, so that you can start playing with getting some of your software loaded on it. So
Excellent.
excited to get that moving. And for anybody else that's listening that's interested in joining, just head over to DeEEP.network and you can buy one of these devices, which will be able to run Mooncast in the near future. And we'll be happy to have you join either of our Discords and get involved with our projects. We'd love to have more support. Thanks everybody for listening. Thanks so much for your time. It was great to catch up again, and look forward to hammering out the technical details as we roll all this stuff live.
Awesome. Good to see you, Ben.
Yeah, likewise.
Take care, y'all.